You've mounted a linear actuator to a hinged arm and it won't move. Or maybe it opens fine halfway through the stroke, but stalls right at the start. Before you blame the actuator, check your geometry, because that's almost always where the problem is. Torque isn't just force times distance. It's force times distance times the sine of the angle between the actuator and the arm. And that angle changes constantly as the arm swings through its travel. At 90 degrees, you get maximum torque. Every pound of force is working for you. But at shallow angles, like 10 or 15 degrees near the start of a stroke, most of that force pushes straight into the pivot and does almost nothing useful. This is the single most common mounting mistake in actuator projects. This calculator handles exactly that problem. You enter your actuator's force output, the distance from the pivot to the connection point, and the angle between the actuator and the arm at any position you care about. It gives you the actual torque in pound-inches, pound-feet, and newton-meters, plus a mechanical advantage percentage, so you can see how much of your actuator's force is actually being converted into rotation. You can also flip it around. If you know the torque your application requires, switch to the force-solving mode. Enter the geometry, and the calculator tells you what actuator force rating you actually need. Think about where this matters. You're designing an automated gate that has to overcome its own weight at a near-closed position where the angle is terrible. Or you're building a heavy lid mechanism for an industrial enclosure. Or you're sizing an actuator for a solar tracker arm that operates across a wide angular range. In every case, checking the torque at the worst case angle, not the best case angle, is what separates a working design from a stalled one. Find the link in the description below to use this calculator and read the full engineering guide.